Again, we can move on to more examples. Write down the gradient function of the following curves. Write down the derivatives of the following. Write down the derivatives of the following curves. We are going to do again 2 questions, then we do other 2. In the first one, we have been given A. We have been given that y is equal to 2 pi x. 2 pi x. And we want to find the gradient function or the derivative of this. So in this one, we simply need to come and know that this one simply means y is equal to the square root of x. From the law of indices, again, you learn that when you have a number, the square root of a is the same as a raised to power a half. And therefore, this one simply means it is 2x raised to power a half. So we want to find the derivative of y is equal to 2x raised to power a half. So we find the dy all over dx. So dy all over the dx, therefore, will be equal to, our constant is 2, then we multiply by a half x raised to power a half minus 1. So we are going to have this as 2 into bracket a half x, a half minus 1, we have negative a half, and therefore we end up getting a half times 2, which is 1. So we end up getting x raised to power negative a half. So that is the derivative of y is equal to 2 square root of x. Then another question, part B. So in that case, we can have it this way, or simply, this one simply means it is equal to 1 over the square root of x. It is simply the same, because when we have it this way, this negative will mean that we are dividing by the square root of that x. So it is still the same. If you write it at that or at that, it's the same. So then question number B, we can have y is equal to x cubed plus 4 all over x squared. We find the derivative of this equation, x cubed plus 4 all over x squared. Again, it is very easy because you just need to write it. Y is equal to, this is a common denominator, so it means that it is x cubed all over x squared plus 4 all over x squared. That's what it means. So you can cancel this by x squared, 1 by x squared, you remain with x alone. So this one simply means you have x power 1, then plus 4 over x squared is the same as 4x raised to power negative 2. From the law of indices again, this is our y. And therefore, dy all over dx, that is the derivative, will be, this is raised to power 1. So we are going to have 1 times x. 1 times 1, we have now 1x raised to power 1 minus 1. Then plus 4 into bracket, we have here negative 2x negative 2 minus 1. So we are going to have this one, this is 0, this is 0. Then we have, therefore, number raised to power 0, 1. So we have 1 plus, this is negative 8, negative 8x raised to power negative 3, which we can simply write as our dy all over dx, therefore will be equal to 1 plus and minus, we have minus 8x raised to power negative 3. So that is the derivative for the equation y is equal to x cubed plus 4 all over x squared. So those are the derivatives. Then we can move on and again do another example. Again, you can write this one just as we have done here. You can continue with this one and say this one is the same as 1 minus 8 all over x cubed. It still means the same, so you can write it in that form or in this form. Then I want us to do some more examples. In this case, we are given the following. We ask the following question. So you can be asked any question from this, provided you know how to differentiate. You can be able to answer any question. Like in this question here, we have been told that find the gradient of the curve. Find the gradient of the curve y is equal to x squared minus 4x plus 6 at the point corresponding to the value of x at x is equal to 3. That's a very good question. We have been told to find the gradient of the curve y is equal to x squared minus 4x plus 6 at the point corresponding to the value of x at x is equal to 3. So we are finding first the gradient of the curve, and when we are finding the gradient of the curve, it is simply finding the derivative, and therefore we start by finding the gradient, which is our derivative dy all over dx, and we have our equation. Our equation is equal to we have our equation. We can start with writing the equation y is equal to x squared minus 4x plus 6, and therefore when we want to find the derivative dy all over dx, we have, therefore we are differentiating them separately. So here we have 2x raised to power 1 minus 4 into bracket x raised to power 0, then plus the derivative of a constant, which is 0. So we are going to have 2x minus 4. That's what we have as the derivative. So our gradient, which is the derivative, is equal to 2x minus 4. That is the equation. But then we are told now to find the gradient to the curve at the point corresponding to the value x of x at x is equal to 3. So here it is at a certain point where x is equal to 3. And therefore our gradient will therefore be equal to, this is the equation for the gradient, but we have at point x, which is 3. So where we have x, we substitute with 3. So we are going to have 2 multiplied by 3 minus 4. So we are going to have 6 minus 4, which is equal to 2. So our gradient at the point corresponding to x is equal to 3 is equal to 2. So when you are given the equation of the curve, you need to get the gradient function, dy over dx, you get the gradient function. Then at that point, you need to get, if it is at point x, which is equal to 3, you substitute x with 3, and you get the gradient, which in our case is equal to 2.